All right, so we have been talking about families of graphs. So we've got some basic ones that we're going to cover that we've been covering. And they all have the same general function, and they all have the same general shape. So any graph in the certain family will have the same type of characteristics. So the first one is linear, and if you look at linear, you can see that part of the word is line. So in a linear function, it is a line, and that line is going to go through the point 0, 0. So it's going to go from low to high, and it's going to go through the point 0, 0, always. Any linear function, excuse me, will always be a straight line. However, it's not always going to go through 0, 0. So any linear function is going to have an equation with just an x with degree 1. You can also write it as y equals x, but since we're in Algebra 2, we like to write things in function notation. So the domain on this is how wide can this graph go? Well, if we go out infinitely far, it's going to go infinitely to the left and infinitely to the right. So our domain is going to be from negative infinity to positive infinity. And I know that this looks like an ordered pair, but it's called interval notation. And the curved brackets just mean that this number is not included. You can't really include infinity because infinity doesn't end. But domain is just all the possible x values that can work for this function. So I can put any number in for x, and that function will still be valid. The x and the y-intercept, I'm not going to worry about the x-intercept, but the y-intercept on this one is 0. And we're not going to worry about the increasing and decreasing interval, but the end behavior we've already talked about. So as x gets more and more negative, so as it goes to negative infinity, the graph goes down. So it gets more and more negative. So it also goes to negative infinity. And then on the right-hand side of the graph, as x gets more and more positive, it approaches positive infinity. And f of x, or y, continues to get more and more positive, so it approaches positive infinity. Now if you think about graphing this equation here, we know how to graph this equation. So positive 7 tells us where our y-intercept is, so I'm just going to kind of eyeball this. Maybe about right here. And then this negative is going to reflect this across the x-axis, so we're going to go down 4 and right 3. So 1, 2, 3, 4, 1, 2, 3. And so our new line is going to go through those 2 points. Like so. All right, now the domain for this one is similar, because if we continue to go to the left, it's going to continue to get bigger and bigger. So the domain is from negative infinity to positive infinity again. There's no breaks in it. It's not going to stop suddenly. So a lot of times if you see one whole graph that's made up of one straight line or one curved line and there's arrows at the end, typically your domain is going to be from negative infinity to positive infinity. Again, we're not going to worry about the x-intercept, but the y-intercept in this case is 7. 1, 2, 3, 4, 5, 6, 7. And you can see that number right here in the equation. And then end behavior, again, as we go to the left, the y this time is getting bigger and bigger. It's getting more and more positive. So f of x is approaching positive infinity. And as x is approaching positive infinity, y is getting smaller and smaller. It's getting more and more negative. So these two have just switched around, and that's because of this negative here. So that just reflects it across the x-axis. The absolute value function is going to look like this. So again, we have a vertex here, and it's just going to go over 1, up 1 on each side. something like this. And so our graph is going to look like this. Okay, so the vertex is like the point, it's the lowest point there. So our vertex this time is 0, 0. So the absolute value function, the parent function, is going to look like this. These little absolute value bars on either side. So again, the domain, this is made up of one solid line. There's no breaks in it, and it's going to continue to grow this direction, and it's going to continue to grow this direction. So the domain, again, is from negative infinity to positive infinity. We're not going to worry about the range or the x-intercept, but we're going to look at the y-intercept, which in this case, again, is 0. We're not going to worry about the increasing and decreasing interval. But the end behavior, as x gets more and more negative, what's happening to y? It's going to positive infinity. And on this side, as x gets bigger and bigger in the positive direction, y is also getting bigger and bigger in the positive direction. So with this one, we have x minus 4 minus 6. So what this tells us in here is that this is going to move 4 to the right and down 6. And so our new vertex is right here. This 3 in front means that this is being stretched out, it's growing faster, and so instead of going up 1 over 1, we're going to go up 3 and over 1. And same thing on this side. So our new vertex is at 1, 2, 3, 4, negative 6. Our domain, again, let me get the arrows on this one. It's going to continue to grow wider and wider, and so that means that we don't have any breaks in it, so it's going to go from negative infinity to positive infinity. And this time we have 2 y-intercepts. We have a positive 2, and we have a positive 6. Sorry, that's not true. We're not going to worry about the y-intercept. Those are our x-intercepts. The x-intercepts are positive 2 and positive 6, but we're not going to talk about those right now. The end behavior, still the same as over here, because as we go to the left, y is still getting bigger. So as x approaches negative infinity, f of x or y is approaching positive infinity, and as x moves along this way, y is getting bigger and bigger. So as we move to positive infinity, y also moves to positive infinity. So a quadratic is going to be a parabola shaped, and again, it's going to go through 0, 0. And so any quadratic is going to have this kind of general shape, but they're not always going to go through 0, 0. So their vertex is not always going to be 0, 0. The parent function for this is f of x is equal to x squared. So anything that has a parabola shape in it has to have a degree of 2. Our vertex is 0, 0. Again, our domain is going to continue to grow out this way and to continue to grow out this way. So the domain is negative infinity to positive infinity. And the y-intercept again is 0. And behavior, as x gets more and more negative, y gets more and more positive. And same thing on the other side. As x gets more and more positive, y also gets more and more positive. This x plus 1 squared means that we're going to move our graph 1 to the left, and this positive 4 means we're going to go up 4. 1, 2, 3, 4. And this negative means that instead of opening up this way, we're going to open this way instead. So it's going to look something like this. Okay, so now the vertex is at -1, +4. And you can see that here. So this +1 changed to a -1, and the +4 stayed a +4. The domain, again, is just worrying about our x's. So it's continuing to go to -infinity to +infinity. I'm not going to worry about the y-intercept. The end behavior, as x gets more and more negative, y gets more and more negative. So they're both approaching -infinity, and as x approaches +infinity, y approaches -infinity. The cubic function is going to look like this. And again, the function is f of x is equal to x cubed. So anything that has this shape is going to be a cubic function, and anything that has this, anything your degree is 3, it's going to have this general shape. So you've got one side decreasing and the other side increasing. So again, our domain, it can continue to go as far to the left as possible. So it's going to go from -infinity to +infinity. The y-intercept is 0. The end behavior is as x is approaching -infinity, as we go this direction, y is also going this direction. So it's also approaching -infinity. And as x goes this way, so to +infinity, y is also going to +infinity. For this function here, we have a translation, -4, +2. So this -4 is going to shift us 4 to the right and up 2. And because this is a negative in front of here, that's going to reflect this across the x-axis. So whatever point was up here is going to be the same distance on the other side, and vice versa. So I have this point up here, this point over here, and so the shape of this graph is going to look something like this. So same general shape, this one's been reflected across the x-axis. Our domain, again, it will continue to grow to the left infinitely, so it's going to go from -infinity to +infinity. We're not going to worry about the y-intercept. The turning point, so on this one, the turning point is 0, 0. So where it turns from increasing, or sorry, where it, yeah. So it kind of curves right here and then starts to go up. So the turning point here is 0, 0. The turning point on this one would be at 4, 2. And end behavior, so this time as we go to the left, y is increasing, so -infinity and +infinity. And this time as we go to the right, y is going down. So as we go to +infinity, you're going to -infinity. Square root function, there's two different ways that you can write the actual function itself. A square root function is going to look like this. So a square root is the inverse of a quadratic function. So what that would look like is the inverse always is going to look like this, but since you can't have negatives for your square root, square roots are always positive, so that's why it's just above the x-axis. Now, of course, you can translate it so that it's below the y-axis, so it can be moved down, but it's going to be because of a translation. So the endpoint on this one is, again, 0, 0. The parent function, you can write it one of two ways. You can write it as the square root of x, or you can write it as x to the power of 1/2. So again, anything that looks like this is going to be a square root function. It's always going to go to the right, okay? We'll talk about when it goes to the left on a later date. The y-intercept is 0. The end behavior, as we go to the left, it approaches 0. This is where it stops. Your domain on this one is from 0 to positive infinity. There's nothing on this side, so the domain is over here is 0. And then as x approaches positive infinity, f of x also approaches positive infinity. On this one, again, we have this negative sign out front. So this is going to shift us to the left 5 and up 2. Whoops, I did that wrong. And I did it wrong in the last one too. I should fix that. Like this. Okay. And, oh good grief. It's going to go upside down. It's going to get reflected across the axis there. So instead of facing up, it's going to face down. And so our endpoint now is negative 5, 2. Our domain is from, there's nothing past negative 5 on the x's. Remember, domain is just for the x values. So there's nothing over here, nothing over here. The domain doesn't start until we hit negative 5. So it goes from negative 5 to positive infinity. The end behavior is as x approaches negative infinity. As x approaches. Actually, you know what? I think this one should be as x approaches 0. Y approaches 0. And behavior as x approaches negative 5. Y approaches 2. And then as x approaches positive infinity, x approaches, or y approaches positive infinity also. We're not going to worry about a cube root right now. The exponential and logarithmic we will do later. The reciprocal we've already done, so this should be familiar to you. Remember that when we do the rational, and this is actually rational function, not reciprocal. So if you want to change that to rational, they're known as either. But rational, the parent function for this one, remember this one is the one that has the asymptotes. So one of the sets of asymptotes, that doesn't show up very well at all, does it? How about we change that? So the asymptotes are going to be on the x-axis and the y-axis, and then the graph of the function is actually going to be in the first and the third quadrant. So here and here. And the function is going to be f of x is equal to 1 over x. So here you notice that this is made up of two separate lines. So for the domain, it's going to go from negative infinity to, and it's going to approach 0, but it's not going to touch 0. And then it's going to go from 0, but not touch 0, all the way to positive infinity. So this just means that 0 is not getting included. It's going to go all the way up to 0, but never going to touch it. We don't have a y-intercept on this one. The vertical asymptote is x equals 0, and the horizontal asymptote is y equals 0. And it's not y equals 0 and x equals 0 because this is the equation of a line, and x equals any number is the equation of a vertical line, and this is the equation of a horizontal line. So I know it sounds counterintuitive to have a vertical asymptote be x equals 0, but this is the line here, x equals 0, and this is the line, y equals 0. And behavior, remember that these both approach the horizontal asymptote. So as x approaches negative infinity, f of x is going to approach 0. And as x approaches positive infinity, f of x is also going to approach 0. On this one, we again have this negative here. We have a -5 and a -3, so this is going to shift us right 3, and this one is going to shift us down 5. So basically what we can do is take those asymptotes and shift those in those two directions. So right 3 and down 5. So 1, 2, 3, and down 1, 2, 3, 4, 5. So our asymptotes are going to converge at that point right there. So we've got one asymptote here, we have one asymptote here, and because of this negative right here, that's going to reflect that across the x-axis, so they're going to be in quadrants 2 and 4 instead of quadrants 1 and 3. So again, the domain is going to go from -infinity all the way up to, but not including this asymptote, which is at 3. And from 3 all the way to +infinity. We're not going to worry about the x-intercept. The vertical asymptote is now at +3. Y equals 3. Sorry, x equals 3. I was writing that right the first time. And the horizontal asymptote is at y equals -5. So end behavior, again, remember that both ends of the graph approach the horizontal asymptote, which in this case is -5. And so as we approach both positive and negative infinity, y approaches both -5. Okay, so these are basically the transformation rules. Any transformation is going to have this general form right here. So if this were our parent graph, we could look at this transformation and see, okay, this is a cubic family. I'm going to be moving it h units in whichever direction based on what the sign is here, and up or down this number of units depending on this sign here. So if we were to look at this one, this -2 here is telling us to move right 2. Inside the parentheses is a horizontal shift, and we change the sign. Outside, this constant back here, that is our up and down, and positive would just mean up, and negative would mean down. So if we have a transformation with a plus inside the parentheses, that means that it's going to be a horizontal shift left h units. Okay, if it's a minus h inside, it's a horizontal shift right h units. If there's nothing inside the parentheses, but there is something outside the parentheses, this is a vertical shift up k units. And if it's minus, then it's a vertical shift down k units. Now, dilations we'll talk about a little bit later, but in general, if we have a number that's being multiplied out front, if a is greater than 1, then this is going to be a vertical stretch. And if a is less than 1, then it's going to be a vertical compression. And the last thing is if you have a negative sign out in front, like we do on this one right here, then that means that it's going to get reflected across the x-axis. Okay, last thing is just identifying which family these come from. So it would be quadratic or linear or absolute value, cubic, rational, all of those. Number 3 is the cube root. We didn't go over that one, but the others you should be able to name. So just make sure that you're aware of what all of those families are, what their parent functions are, what the parent graph looks like, and how those transformations affect what each of the functions would be written.